Section 5.7 deals with how to solve a recurrence relation by iteration. And I've been trying to do that with all the problems in Section 5.6, with the exception of the Fibonacci, kind of as we went along. Section 5.7 also does this in particular for two very important sequences that you see popping up many times in different forms. And they are the arithmetic and the geometric sequences. Now, we've actually talked about both of these a little bit before. And these are described in quite a bit of detail at the beginning of Section 5.7. And it shows you how to work with arithmetic sequences. At the beginning of this chapter, and it shows the definition of an arithmetic sequence and the formula for it on page 307, and it does the same thing for a geometric sequence on page 308. What I've done in this one table is compare the arithmetic and the geometric sequence and shown how to work with each one of them in both a recursive and explicit way. The arithmetic sequence is one in which basically you start with some initial location and then you add something every time. And the letter D is usually used here to say it's the difference. So we could be adding a difference each time. So if you were just adding 1, if you started at 2, you'd be counting 2, 3, 4, 5, and so on. This D is the difference. And the difference could be a negative number, so sometimes arithmetic sequences go down, so you could also think of that as subtracting something. Well, if we're doing this recursively, you're just going to have to keep adding or subtracting whatever that difference is. But if you want to quickly get to the final result, we can use an explicit formula, start with our initial case, and add the difference times the number of times we're using that difference, the number of times we're doing the iterations. Now, a geometric sequence is different in that we are multiplying the previous one by some number. We usually use R for as a ratio. We multiply by the ratio. We did a geometric sequence before where we were multiplying by 2, and we did that with the coins on the checkerboard. We also did that with seeing how ancestry works with the ancestors and looking at a family tree. We saw that ratio, that could be a bigger number, so we could be multiplying by 3 or 4 or 5. We also saw that could be a fraction, so it would be making something get smaller. So each time we take the one before it and multiply by the ratio for the recursive formula. If we want to immediately go to a particular term in the sequence, a sub n, we can take a sub 0, the initial place, and multiply it times the ratio to that exponent being n, the number of times. And I was doing that very quickly in the previous problem on compound interest to show that because compound interest is a geometric sequence, we're multiplying by an interest rate each time, so we can quickly get there by knowing the explicit formula. There's a group of problems in this section where basically you have to look at it and identify if it's an arithmetic or a geometric sequence, and then use that information to be able to solve the problem. We'll take a look at a few of those.